All right, guys, we've talked a lot about loops. Moving on to the next chapter. If you check the content mind tab section, there's a link to the Unit 5 test, mind tab test on it. Just go ahead and take that if you haven't already. Wouldn't blame you if you hadn't already because we weren't done with the chapter, but now we are. All right, so the last page, pretty much, of the loop chapter. What can you use loops for? Accumulate totals in business reports and to reprompt the users for valid data. There's a whole bunch more purposes than that, right? You're just going to be repeating an action until a certain case occurs. You're going to keep moving Pac-Man around the screen until he hits a ghost. You're going to keep repeating the game until you run out of Pac-Man lives, right? You're going to keep looping in order to update, the screen for whatever purposes that you're updating it, whether it's a game or whatever. So in the selection structure, the two logical paths from a test join together following their actions. So we're talking about selection structures, right? Diamond goes two different ways, joins back together at the bottom. But in the loops, there's only one path that continues to the bottom. The other one goes back up to the top to repeat the test. And remember the three steps of your classical loop. You initialize up at the top. You have your test. Then you have the body. Well, I guess that's 4 steps, but even if you ignore the body. And then you have the update. So initialize, test, update. Whatever term the book used for update. I can modify. I forget what. Okay, so arrays. In Python, we call them lists. Similar concept. Python doesn't have what C++ or C would call a true array, or Java. But that's okay. We can kind of ignore that point for now. And if you go on and take C++ or Java, then you will learn the differences between a list and an array. So as we talk about this, we're going to be learning the concepts of arrays, but I'm going to be teaching you the concepts of lists, which are very, very similar. So it shouldn't be too confusing. So we're going to learn about arrays, and then we have some other objectives, including how to use a loop to process an array, how to make sure that you're within array bounds. Like think of an apartment building, except that the first apartment is apartment number 0, and the last apartment is apartment number 99. You better not try to move into an apartment number that's less than 0 or greater than 99, right? Those don't exist. In some languages, it'll cause the program to crash if you try to do that. You can search an array for a match, meaning that you can go through those apartments looking for the specific person that you're looking for. That's what's known as searching for an exact match. And you can use parallel arrays. What is a parallel array? Suppose that each apartment has a mailbox, right? The mailbox is linked to the apartment occupant by their apartment number. Otherwise, Joe, who lives in apartment number 22, wouldn't know which mailbox to go to. But instead, he goes to mailbox 2. So you have 2 different lists, 2 different arrays. And for now, just pretend those terms are synonymous, just like function and module are. And they're linked by their number, right? The apartment number, the apartments, and the mailboxes are linked by their apartment number. And you can think of all sorts of places where parallel arrays are used, even if you don't think of them in those terms. Like a spreadsheet. You have a list of months, and then you have a list of sales figures for those months, right? And they're side by side. And you have your row numbers. Well, those items are linked by row numbers. The sales for January, you have the month named January, and you have the sales for that month. They're linked by the same row number, right? Same idea. Why are they called parallel? Well, you line them up, right? So what is an array? It's a series or list of variables. And I know that I've brushed upon them in the past. But what we've been doing classically is that a variable has one value, right? I have a first name. It's equal to Jeff. I have a last name. It's equal to Thompson. Great. If I do something else, it's going to replace that first name. Like if I ask you for your first name. You tell me it's Dara. Okay, great. Now we have a different first name. The old first name is forgotten. But a list could hold all of our first names, right? Jeff, Dara, Susan, whatever. You know, that way you can process an entire series of data rather than just one thing at a time. And so all variables share the same name, right? First names, right? We're going to give one variable name to all of the values. Then how are we going to distinguish which first name is which? For that, you use an index number, also known as a subscript in this textbook. So first name's subscript 0 is me. First name subscript 1 is Dara, and so on. So you keep going down, and I prefer the term index number, but I also like to teach to the textbook, so I'm going to be using the term subscript. Again, those are two terms that are pretty much synonymous. Why don't we make a little list so far? So an array, ACO list, is a series of data elements with the same name in computer memory. That's my definition. This is their definition. If I ask for a definition of an array and you give me theirs, great. If you give me mine, even better. Puffs my chest with pride. So all variables share the same name. Talked about that. And must be of the same data type. Not true in this language. So I'm not going to copy that. Each variable has a different subscript. Each element has a different subscript. So you could have an array called names. And name subscript 0 is equal to Jeff. Names subscript 1 is equal to Dara. Name subscript 2 is equal to Joe, or whatever, right? And you just keep on going. So when we define this array, we might have defined it in our language like this. Names is equal to, we might have said, okay, the first element is Jeff, the second element is Dara, the third element is Joe. Now the textbook calls them different variables. That's not a different variable than that one. It's a different element in the series, right? This is the variable. Kind of disagree with the book. Hope you can keep these things in mind. So each element has a different subscript, also known as an index. Note that the book calls each element in the series a variable. But really, the variable is the array name. So the book is wrong. Okay, I'm going to delete that. Here we go. So we have an array. We have 3 elements in the array. If we try to access past the end of the array, it goes kablooey. Names subscript 3 does not exist. Will crash the program if we try to access it. And we could prove that to ourselves. We could load up Python. We could create an array list of 3. Notice this. What is the length of this array? This array has a length of 3, right? So what items can you access? 0, 1, and 2. Why is that? Because if you have 3 items, but you're counting from 0, you have to stop before you hit the length, right? 0, 1, 2. Well, what do you know? I've got 3 elements now. If I try to access element 3, I have to be careful with the fingers I'm using here. 0, 1, 2, 3. Right? I'm past the end of the array because I only had 3 elements. So the index number and the length are not the same. If you have a length, like if it's 100 items long, you can go from 0 to 99. If it's 1,000 items long, you can go from 0 to 999. And then going past that is an error. So the elements are contiguous in memory. Go ahead and accept that even though it's not true in Python. What is an array? It's a list of elements and a computer arranges them contiguously in memory, right? So that this element occupies the next set of bytes from this element and this element occupies the next set of bytes from this one. And I said that's not true of Python. It's because Python doesn't support strict arrays. They support lists in which the items may be anywhere in memory, but Python keeps track of them for you. Which one is first, which one is second, which one is third. So we're going to go with this definition. Array elements are contiguous. Contiguous is a fancy word, right? But it just means in sequence. One after the other. And it's not that the textbook is dumb, it's that they're covering a lot of languages. A lot of languages do support strict arrays or classical arrays. You know, people have been using arrays since the 1950s when programming languages were non-existent or very primitive. Python is a very advanced language, but the designer of it decided not to support arrays because he could do everything that an array does with a list. Now, what is the difference between an array and a list? This doesn't talk about it. An array is fixed in length. If you have 100 apartments and you want to let Mr. 101 move in, too bad, you have 100 apartments. What would you need to do if you were going to add Mr. 101 to it? Well, in computer terms, you have to destroy all those apartments, create a new apartment complex that's larger, and then let him move in. Now, in real life, would you do that? No, you just go and add a new, right? A new block of buildings. But that's the thing about arrays. They're fixed in length. Once you have 100 elements in it, if that's the length to which it was declared, too bad. You can't add any more to it. A list is dynamic, and so it has some code behind the scenes. It's a library that's managing it so that you can add as many items to it as you want. You can delete as many items from it as you want. So a list is more flexible than an array, which is why Python uses lists. But again, for the most part, in this class, we're going to use the term synonymously. And then when you go into another language that supports strict arrays, the professor, probably me, will make a big deal about the difference. I may put that in as a comment. An array in other languages is fixed in length. Lists, on the other hand, like Python's lists, grow and shrink as needed. Another idea of a fixed length array is what if you have 100 people in it and then you want to remove person number 10. Okay, well, you have an empty apartment, right? Apartment number 10 is now empty. In a list, you'd probably want everything to get shifted over one, right? So that there was a new person number 10, right? Because you want all of the data, to be contiguous. But in an array, it wouldn't happen. You just have an empty block in the middle. And then if you wanted to fill that space in with the rest of the data, you'd have to move each over by one by hand. So the fixed in length business is really important for the languages that support strict arrays, true arrays. Adding data values is known as populating the array. Okay, I'll try to remember that. What is the subscript? Here they're saying the terms are synonymous. It's the position number, the apartment number, the number of the mailbox. It's the number of the value, the element. It's a sequence of integers, right? You don't have, unless you're in, Harry Potter world, apartment 13.5, right? Or train, whatever the fractional train value was. So anyways, they're always whole numbers, right? You can't access element number 13.6. All you can do is access element number 13. They keep calling them item, element in an array, less than the number of elements. Subscripts are always a series of integers. Just remember what I said. If you have 100 of them, you can go from 0 to 99, which is why it says starts at 0 and goes one less than the number of elements, the length of the array. Now that doesn't mean that the items in the array have to be whole numbers, just the index numbers, right? That's element 0, that's element 1, that's element 2. These items can be anything. They can be turtles, they can be floats, strings, you know, whatever. They can be any kind of data. In a classical array, they have to all be of the same type. That's how we will do it in this class, even though Python lets you do weird things like make element 0 a turtle, element 1 a string, and so on. Again, Python's a slightly weird beast because it's, you know, trying to do some more complicated stuff. So an array is the list of data items in contiguous memory locations. We've already said that. Each data item is an element. Might as well say that. Each array element is of the same data type and the same size. All right, I'm not going to copy that stuff. If the MindTap test asks it, just look it up. You have your PowerPoints and you have your MindTap book. Just open the MindTap book in a different window and scroll up and down, you know, and search and find your answers that way. Each element is differentiated from the others by the subscript, also known as the index. Yeah, sure, why not? We already said that, but we'll say that again. I will use the term subscript, though, quite often, as well as index. And the time I will say that is if I'm giving you some code and I'm reading it aloud, I'm going to say names subscript 1 is equal to Joe. I won't always say names square brackets 1. I'll try to. But if you hear me say subscript and we're typing in code, it means put it in square braces. And for the guys in the back of the room who can't see what we're doing, those are not parentheses, they are square braces. That's how it tells the difference between a function call, right? If it said this, name subscript 1, it would look for a module named names. There's probably not going to be a module named names. But if it sees that index number, that subscript in square braces, it knows that we're talking about an array. So use square brackets for your subscripts. Indices. I don't want to be all fancy and say indices. I'm going to call it index values. We know this. Subscripts start at 0, they go one less to the length. There's a command in Python to give you the length of the list, right? Because otherwise you wouldn't know when to stop. That's different from C, where they don't give you a command for figuring out the length of the array, which is really irritating. Because you're not allowed to go past it, but they don't give you the length of it. Each array element can be used in the same way as a single item of that data type, right? So if we have 3 pieces of data, nums is equal to 1, 2, 100. If I need to do something with these pieces of numbers, you know, v is equal to 1, great, that's an integer. V is equal to nums subscript 0, that's also an integer. Everything that we could do with the number 1 or the variable v from here is also true of num subscript 0. And they should all be of the same data type, so they are all integers. If you were passing that data to something that expected floats or whatever, if you passed in a variable, great. If you passed in an array element that was a float, great. They're treated exactly the same. Skipping that slide. Definitely skipping that slide. Alright, maybe I better not skip it. They're spending 20 pages on it. How an array can replace nested decisions. Well, we've talked about what nested decisions. Those are the if, else, if kind of thing. Is department equal to 0? Yeah. Add 1 to the counter of the departments for 0. Is the department equal 1? Add 1 to that position. Is the department equal 2? Add 1 to the variable keeping track of that department's. Is it equal to 3? Add 1 to that counter. Is it equal to 4? Add 1 to that counter. Otherwise, add 1 to the 5th counter. Now, if you ever see something like this, where we're keeping track of a whole bunch of counters, you might be able to replace those counters with arrays. And that's what they're going to do. They're going to declare an array, you know, of 6 elements. 0, 1, 2, 3, 4, okay, 5 elements, sorry. So we're going to have 5 different elements here in our array that we can increment based on the if decision. But the if decision is going to look a little bit different. So here we go. Is the department equal to 0? Put that information in the first element of the array. Else, if the department is equal to 1, put it in that element of the array. Else it's equal to 2, put it in that one. Else it's equal to 3, put it in that one. We have one piece of data that is storing all these counts, rather than a whole bunch of different ones. And here's our if statement for that, which we wouldn't write like that. We would use elifs, right? Rather than else if, we would use elif. And the reason why is that when we were done with all of our elifs, they would be lined vertically rather than this stair-step effect, which is really ugly and hard to edit. Same idea. If the department is 0, then add 1 to that element of the array. Else, if the department is equal to 1, add 1 to that element. Else, if the department is equal to 2, add 1 to that one. Else, if the department is 3, add 1 to that one. Maybe we ought to actually code something like this, but we would code it a little bit more efficiently. Probably where they're going here. Else, if it's equal to 4, add 1 to that element. Else, add it to that element. But you could simplify the code a lot further, right? Because here and here, these values are the same, right? They've already got an index number here, and they've already got an index number here, and they've already got an index number here. The only place that they don't have an index number that matches the position in the array, or the department number that matches the index value in the array, is in this 5th case, where it's not equal to 1, 2, 3, or 4. You don't even need all of that stuff. You could replace it with a single if-else statement. And I think that'd be cool to do. It won't take us long to code it, so let's go ahead and do that. We're going to write a little loop that asks the user for a series of numbers, and then based, kind of like what if you were going to roll a die, a 6-sided die, and you wanted to see if it was perfectly balanced. So you were going to roll it 6,000 times and make sure that the number of 1s almost equal to the number of 2s, almost equal to the number of 3s, whatever. And if it never rolled a 3, then great. Oh, wait, I want to show y'all something. If I can spot it real quickly. Mentioning dice. I'm probably not going to be able to find it fast enough. All right, I'll just tell you what it was. They found some dice, like from medieval Sweden or something, like from the 800s or whatever. And yeah, they were cheaters' dice. How? Because they turned the 2 spots, you know, like that. They added 2 more spots to make a 4. And they took the 3 side and they added 2 more spots to that one to make a 5. So the die had 2 4s and 2 5s and no 3s and no 2s, and it had a 1 and a 6. And they hoped that if you roll it, then you wouldn't notice that there were 2 5s on it or 2 4s on it. So it was not a weighted die, but you would never roll. The average was much higher, and it was kind of clever, and it was kind of interesting to know that even in the medieval times, people were trying to figure out how to beat gambling systems. Really, that's all that you could imagine that was used for. All right, back to this. So let's launch idle. I said, let's launch idle. Here we go. File new. Is April 12. Save as April 12. Don't put it in your Python directories. Put it in your own. I don't know why I'm talking in this musical sing tone voice. All right, April 10, 12. All right, so what, I'm going to just flesh out some pseudocode first. We're going to loop. How many times are we going to loop? I don't know. Let's ask the user for 10 numbers. That'll get annoying if we have to do it over and over, but you know, to begin with, it'll be okay. So we're going to do a loop for x. Why don't I just type it in Python? Alrighty. Forget the pseudocode. For x in range, starting at 1, and we've done 4 loops, so if I want 10 numbers, what am I going to make this one? 11, exactly. Counting by 1. But I don't have to put the comma 1 because it is assumed if I leave that off. I like putting it, but we don't have to. And maybe I will. Okay, so there we go. Now we're going to ask the user, roll a die. Someday people are going to just stop using the word die because everybody calls it a dice, right? Even if you just have one, it's a dice. Roll a die. Tell me the number. Let's get that value. Die, looks so violent, is equal to input. And in this case, we don't want to convert it to a float because remember our index values can't be floats. It would crash if we tried to do that. So we are going to convert it into an int. Die is equal to int die. All right, now we have a number. They type in 5. We have a number. Great. All right, now my example is kind of going off the rails here because what is the first element of the array? What is its index number? 0. And what is the first element number on your die? It's a 1, right? So we're going to have to do just a little bit of manipulation when we declare our array. We're going to make it 7 elements long so that we can actually access up to 6. Remember, if the array was of length 6, all we could do was 0 through 5. But I want to be able to put in the 1 and the 6 and the stuff like that, so I'm actually going to make it 7 elements long. So I guess I'm going to call this tally. All right, we're keeping track of all these values. And I need it to be, whoops, square braces, 7 elements long. So I'm just going to do this, 0, 0, 0, 0. I need 7 of those bad boys. That's 4 of them. 5, 6, 7. I just kind of put that space there to distinguish it. 7 elements, so we can skip 0. I'm not going to put the extra comment that because the die cannot roll 0. Alrighty. So now what we're going to do is we're going to say the tally for that specific number that was rolled plus equals 1. Or if you prefer, but it's a lot more typing, tally is equal to tally plus 1. That's a lot more typing, so I just go with that. That's enough. Now we're going to get down here to the bottom, and we're going to print out the values of that array. We're going to use another for loop. Wouldn't have to use a for loop. You could use a while loop, but we've already seen, right, that for loops are more efficient for writing these things. So I want to go element starting at 1 and counting up to 6. So again, we're going to have to do our little range trick of the range being 1 higher than our maximum number of elements. So really, this is 1. What is the length of our array? Why don't we just get the length of the array? LA, for length of array, is equal to the LEN of our tally. And it's going to report that the length of the array is 7. All well and good. For x in range, starting at 1 and going out to LA, the length of the array, skipping by 1s each time. If it'd make you more comfortable, we could just hard code that as 7, right? But then if we wanted to do, you know, like a 20-sided die for your D&D or Pathfinder fans, then we'd have to change, you know, that number as well and everywhere else. And if we just base it on the length of the array, then we don't have that magic number there. So I am going to call it LA. And let's just print them out. Print. We rolled a, comma, and let's print out x, which is our die roll, this many times, colon, end quote, comma, and we have to access our array element. Tally at x. Now this part may be a little bit more abstract than the rest of what we're talking about. Or maybe all of it is abstract at this point. But as we keep doing it, it will gel. And maybe it already has. So what is this doing? We're getting a value between 1 and 6, and then we're increasing each number in the array. You know what we could do? Let's print out the list, the array, every time we add one to it. So we're going to come up here and we're going to add a print statement. Just print the tally. It's not going to be nicely formatted, but we're going to see the numbers increase. That'll help us conceptually. When we're done with this, we'll probably comment that out. All right, that should be a working program, barring any syntax errors or logic errors. I could have messed it up. All right, I made a syntax error already. What's wrong here? Yep, put the colon there. Every time you start tabbing, you have to have a colon on the prior line in this language. All right, roll a die, tell me the number. 5. You see what it did? It upped, incremented element number 5. 0, 1, 2, 3, 4, 5. Roll a die, tell me the number. I'm going to roll a number 5 again. See what it did? Now I'm going to roll a 1, the lowest number on our die. There. I'm going to roll a 6. All right, then amazingly, I roll a 7. All right, it blew up. Why? Because that's out of bounds. The length of the array is 7, so the highest number, index number we could access is 1 through 6. Now I'm going to run it and not getting any syntax errors, so all my numbers are going to be between 1 and 6. I'm just going to fill them in, right, until it stops asking me for numbers. And there we go. Hopefully this data is right. I wasn't paying a lot of attention, but I didn't roll any 5, and somehow miraculously I rolled every other number exactly 2 times. Whatever data you enter, will modify those results. So we didn't have to have 6 variables to count all those tallies. We just had to have one variable, but it was a list. It was an array. All right. That's fun and all, but every time we run this program, we're going to have to type in 10 data values. It'd almost be more fun to generate those numbers at random, right? And then we could run it not just 11 times, we could run it 1,000 times and see the tally. So what am I going to do to support that idea? I think I'm going to just comment all this code out, and we're going to rewrite it to use a random number function. So I'm going to choose all that stuff and use format comment out. It's still there, we can learn from it, but it's commented out. So to use our random number generator like we did in our guessing game, we have to import the random library. So import random. Normally people like to put their imports up at the very top of the program, right underneath their comment block, which I've been forgetting to show you, your name, the date, whatever. Array demonstrations, whatever. Okay. And then they like to put the import random up at the very top. So I'm going to do that. I'm going to add the import random to the very top. But if you left it here, right after our commented code, that's totally cool too. Now we could generate like 10,000 numbers in the blink of an eye on a computer because, computers are fast and this is not the fastest language. In a language like C, you could generate, 100,000 numbers or whatever. Computers are amazingly fast anymore. So why don't we just generate 100 numbers first? For X in range 1 to 101 because I want 100 numbers. If it made me feel better, I can make that a 0 and make that 100 to generate 100 numbers. But I'm okay with this. Let's get our random number. Die is equal to random dot next, and I forget if the I is capitalized or not, so forgive me, between 1 and 6. And then this line is going to be the same. I could just copy it. Now I'm going to type it again. Tally for that value, tally subscript die, and after this I'll wander around and make sure everybody's doing okay. Plus equals 1. And if we print the tally out, it's going to make the program run much more slowly. But for now, I'm going to go ahead and do that. Maybe I'll even print the die number and then the tally, right? Just so that we can see them both. So I'm going to print die, comma, tally. Sounds so violent. All right, there we go. Let's see if I have any syntax errors, because I'm wondering, yep. It's probably randint rather than nextint. Let me change that, you know, and if I Googled it, I would know right away. Let's find out. Yeah, there we go. Okay. So since I only did 100 numbers, it didn't take that long. We can scroll up and see what it's doing. Right, it rolled a 5, so it incremented that one. It rolled a 3, so it incremented that one. It rolled another 3, so that went up to 2. It rolled a 4, so that one went up to that. And we could get down here. And we find out that we rolled a 1 13 times. We rolled a 2 13 times. And these also, since we did it exactly 100 times, these could serve as percent, right? 13%, 13%. For some reason, our random number generator is really fond of 3. And so it rolled 21 times. All right. Stop it. Make sure it's working for everybody. So if I run it again, I should see a fairly flat distribution, right? And if I increase the numbers, instead of rolling just 100 times, if I roll it 1,000, what do I have to change to get it to roll 1,000 times? I'm just going to change our range here. So instead of rolling 100 numbers, I'm going to roll 1,000 of them. If I took that print statement out, it would roll a lot more quickly, right? This is getting kind of tedious. So there we go. It took a while. But see, it's a fairly flat random distribution, meaning that it rolled 160, 16% of the time. Excuse me, it rolled a 1 16% of the time. It rolled a 2 16.2%. It rolled a 3 17%. And how am I magically getting these numbers? I'm just dividing them by 1,000 in my head. If we went and modified our code, we could divide, the number of rolls by the maximum number of rolls and get the percentage. But they're all pretty close to the same. But let's figure out what happens if we roll 2 numbers and add them together. To do that, we really have a lot of typing here that I would hate to have to just recreate. So I'm going to do the bad thing and copy and paste. So I'm copying everything from my for statement all the way down to the bottom. But I'm going to put a comment here about what we're doing. Now let's tally 2 dice, not 1. And then paste that stuff. We need a new tally array. Why? Well, for one thing, we're kind of going with the idea that an array is fixed in length. But in others, if you're rolling 2 dice, you can get values of up to 12, not 6. So we need our array to support indexing elements 1 to 12. So we're actually going to have to make it 13 long, right? Because we can access elements up to the length -1. So we're going to recreate our tally array. So tally is equal to, and it needs to have 13 elements in it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and then one more. And don't mess up the placement of the commas like I almost did. You can delete all the spaces once you're sure that you have 13 zeros. And I made another mistake because I lectured about not doing a parentheses there. And lo and behold, I put a parentheses there. So that should be a square brace. Alrighty. We need to add two numbers together, right? So we're not going to just randomly generate one random number. We need to add two of them. So let's do this. We're going to just, the easiest way is just to add a plus and then type that in again. Random dot rand int 1, 6. And I think I'm going to lower these thousands back to 100s just because they're taking so long to run, right? I don't want to sit here and watch these print numbers for print forever. So change that one to 101 rather than 1001. Change that back to 100 numbers, and then scroll up and do the same. Why did I change this to 13? Because that's how many elements are really in the array, and I was just kind of making a note for y'all. Alright, so I'm going to scroll up and change that other 1000 and 1001 to the right values, just because I don't want it to go so long. So 1, 101 for 100 numbers. And if you don't do that, you're just going to have to watch a little longer. The best thing will be is when we comment out that print statement. But let's put a print statement here describing how this data is different than the other one. I'm just putting a couple stars there, and I'm going to say tally for 2 dice. And then a couple more stars, and in quote and in parentheses. That'll make it look, you know, kind of pretty. I should do the same thing for my first print statement. My first printing of the tally. My first for loop that prints the tally. All right, so if we look, the tally for the 2 dice. Notice that it says we rolled a 1 this many times. And if we run this code several times, I'll bring the code back up so you can type it in. If we rolled a million of these, are we ever going to see it roll a 1? Now think about what we're doing. No. Why? Because 2 dice, the minimum value we can roll is 2. So we don't even need to print that one out. I'm going to modify my range in order to skip printing out element 1. So what change do I need to make here so that I'm not printing out element 1 of the array? I'm printing out, 2 through 12. Give you a hint, it's in one of the last 3 lines. I want to stop it from printing out element 1. I want it to start at element 2.
For X in range 19.
Exactly. I just want my for loop to start at 2 rather than 1. Alright, so the changes we've made is that we lowered all the thousands back to 100 so it wouldn't take so long. And what I'm about to do next is to comment out the print statement. There we go. We should see that we rolled a 7 more often than anything else. But we didn't. That's curious. I'm going to run it again. If we increase the number of rolls to 1,000 or 10,000, then the distribution will look much more like a bell curve. Okay, and this time 7 was the most often, but 9 was right there with it. Kind of weird, but we'll go with it. Now let's comment out this print statement so it'll go lickety split. Right? That one. We don't want to print our tally 100 times or 1,000 times. And then just go and comment that same line out in your other for loop, right? Print die, comma tally, scroll up and comment it out as well. I'm getting the feeling it's about time to do another walkabout, but let me come up here. And inside both of our 4x in range, 1 to 101 for loops, comment out that so it goes really fast. We're not going to get to see them increase, but There we go. We're still not getting 7 more than any other number, which is kind of bugging me, so maybe I'm going to change those values back to 1,000. Right? So instead of just rolling the die 100 times, or the dice, we're doing 2 now, I'm going to go back to rolling at 1,000. So on this bottom, this for loop right here, change those numbers back to 1,001 and our comment back to 1,000. And there we go. This time I got the results I was expecting. We got 7 more often. But you know what? 6 and 8 are pretty close, right? And then 107 is a little less than that, you know. 2 is the least. And if we converted these to percentages, we would just have to divide those values by the numbers that we rolled. So why don't we divide our tally as we print them out? Not by 1,000, because what is a percentage? You divide it by the total number and then multiply it. Well, okay, I'm going to first try dividing it by 1,000 and see if I like the way it looks. But I think it's just going to be dividing by 10 or something in order to make it look pretty. Yeah, that's not good. All right. If we divide it by 10, is that going to make it look prettier? Make it look really like percentages? All right. I'm liking that, but it's kind of confusing the issue, so maybe I'll remove it. I could print that number out and then put, you know, parentheses after it, and, you know, it would be an accurate representation of the data as long as we told them that we were doing percents. But I'm going to take that out. I'm not feeling that. Future generations would wonder why I divided by 10 there. What is that doing? Okay. And that 10 would be a hard-coded value, right? Because if we changed it to roll 10,000 times, then, you know, we would have to change that 10 to something else. Let's try that. Let's make it roll 10,000 times. So change that to 10,001. See how fast it does it. See, computers are really fast. Change it to 100,000. Eventually we'll hit a point where it's still taking a long time. Right there. That's not bad though. Repeating something 100,000 times, you know, in the span that we watched it go, that's pretty dang fast. And if we did it in a more efficient language like C, there's a reason why C is more efficient than Python, and I haven't really explained why. Alright, so I'm going to wander around, make sure that everybody got this working. I'm going to scroll that first bit of code off because this is all the code that we've added. Alright guys, so in a way we kind of got abstract here before we started talking simple. Let's define some simple lists. Books is equal to, and then list, you know, 5 or 6 of your favorite books, whatever. Gone with the Wind. Twilight, my favorite. Alrighty. Peter Rabbit. Peter Cottontail, what are they called? It's like there's 2 books with the same name. And when you're defining a list like that, you don't have to put it all in one line. It's great. You want to, but I'm going to just go on to the next line. And I want 6 books, and my brain is beginning to shut down. So Programming 101, and then Jurassic Park, and I need one more book, The Shining by Stephen King. There we go. Now let's say I really don't like Twilight and I want to replace it with something else. What element number, index number, is Twilight?
1.
It's 1 because this is 0, right? So I'm going to change books subscript 1 to a different book. cooking with garlic. Now here's the cheaty way of printing out our array. Just print books. But if I ask you to print an array on an exam, I'm not going to want you to do it in that cheap and cheaty way, which is why I'll say print it with a loop. All right, and so down here, printed out my books. Gone with the Wind, Cooking with Garlic, Peter Cottontail. All right, so there we go. We changed that element number. There are other Python commands for like inserting an element number, inserting an element into the middle of it, or appending one to the end. Now those ideas are not, you know, array ideas. You can't append to the end of an array without changing the size of the array. And I told you there's a fixed length. You can't delete from the middle of the array without moving all the elements over by one. So for now, I'm going to skip appending to them. We'll get there. But let's print the array out with a list. It's going to look very similar to what we did here. We could use a for loop. We could use a while loop. I think our while loops are feeling lonely. We haven't used them for a while. So I, short for index, is equal to 0 because we want to print that one out first. I is less than 6, but that's cheap, right? Because we really want it to be the length of the array, because if we went and we made our list of books 5 or 7 or something like that, it wouldn't get them all. So I don't know why I put less than. That was supposed to be an equal sign. No, it wasn't. But while I is less than the length of our books array, print I love, end quote, comma, books, subscript I, the one at that position. And according to our rules about loops, what are the 3 things you have to do? You have to initialize your counter, you have to compare, you have to test it, and then what's the 3rd thing? You have to alter. Thank you. That is the correct term. I keep saying update. The book wants us to say alter. There we go. And it's printing out my list of books. If we use a for loop, it would look almost exactly the same. For I in range 0, comma, len books. And then our same print statement. Print I love, end quote, comma, books, subscript I. And we don't update it because that's done automatically by the for loop. And I've drifted away from putting the 3rd number in, the comma 1. But hopefully you understand that if I leave off that comma 1 on my for statement, that means it's automatic. Also, if I'm starting at 0, I could leave off that first number. But I don't want to get too weird. But I could do that. That'd be totally fine. But I like to keep things kind of congruent between lectures. So I'm going to leave that. Let's make sure it prints a list of books twice. Yep. There is one more way to print a list. Well, I mean, like there's probably a million. With a different syntax, a simpler syntax. I'm going to go ahead and show it to y'all. The book's probably not going to show it to you because it's pretty specific to this language, although Java and C++ have some variations of it. Those languages call it for each. So I'm going to, if I say for each, forget the word each. This book doesn't support the word each, but it supports the, this language supports the concept but not the word. So for each element, or just E maybe, in my books, print I love, end quote, comma, E. All 3 of those work to print out this list. Is there an advantage to using one over the other? Well, the third way is nice and it's the cleanest syntax, right? The first way is just the same as a for loop, but with a couple extra statements, so I wouldn't do it like that. There is one fundamental difference between these two, though, is that E is a copy of each element, and if you change E, it doesn't change the array. Whereas this actually is the array. So if I change books I for whatever reason in my loop, then it actually changes it. I'm not going to focus too much on that right now. This is a good syntax for printing out lists or for adding up numbers in a list, traversing a list. I think the textbook called it something else, or maybe I'm thinking the C++ book, but traversing the list is just going from one end of the list to the other. I definitely want you to have these two memorized. That's like test material right there. I may not specify which way I want you to print the list, in which case you could get away with using one or the other. But do memorize them both. And you're going to see me start using this syntax more and more. Because why? Because it's easier to type. Right? I don't have to type in book subscript I just type in that little E there. I'm getting close to ending. The reason why I chose I is for index. The reason I chose E is for element. Sometimes I choose V for value. You'll see me kind of veer between those two things to be kind of inconsistent, but I love using I to mean the index. So I will almost always use I. You know, but again, variable names are meaningless except to the people. If I wanted to call this, you know, for, you know, Barney in books, print out Barney, it would work just the same, because a variable name doesn't matter to the computer, it just matters to us. All right, we've been typing a lot. We've been ignoring the slides. Let's go back in. I didn't check to see if anybody had any typos in that last bit of code. When we were printing out the favorite books, stuff like that, we all good? Okay. Like I said, they go a long way on explaining this concept. Like half of the PowerPoint is based on how an array can replace nested decisions. I may have y'all skip the MindTap exam for this chapter and write my own instead, just because I'm worried. I better look at it, make sure I agree with it. So using constants with arrays, you could hold the size of the array. You could use constants as array values. That's kind of strange. You could use constants as subscripts. Now I think that's a silly idea, right? Because if you're stepping through the array, you don't have a constant. And does our language really support the idea of constants anyways? No. But in most languages, this is a good idea. If you have an array that's declared out to 100 elements, make a variable called size or something, right, equal to 100. We can just use the len function to get the size of the array. So we don't care about the idea of using a constant to hold the size of the array. In other languages, it's a good idea. Why? Because you may not be using a language that has an len command. Like I mentioned, C and C++ don't have the len function. So when you create the array, you better also create a variable that contains the size of the array. You say, I want an array of 1,000 elements. The next thing you need to do is to say size equals 1,000, or vice versa. Here's how that would look. And you don't have to memorize this. But in those languages, you would do something like this. Const int, this means constant value. Size, and since it's a constant, we'd probably type it in uppercase, is equal to 1,000, and then we would make an array. We would say, you know, books equals books to 1,000. Something like that. That's not good syntax, but that's the idea, right? And then if we wanted to use a for loop, we would say for, you know, x in range 0, comma, size, like that. Now, the one thing that this language doesn't support is that idea, right? Pre-allocating the array to a certain number of elements. That's why we've been doing this business right here. Whoops. Where I initialized it by hand. That's kind of cheesy. It'd be nice if I could do this in one command, right? It'd be nice if I could say tally is equal to new array of 1,000 elements, right? Something like that. Because if it's going to be 1,000, I don't want to have to type in 1,000 zeros in my initializer. And by the way, this is called an initializer list, at least in the languages. We'll see what the book calls it. Is there a way to predefine our array to a certain length in this language? I hadn't even ever asked myself this before. Python, define a list with size. Create an empty list in Python with a certain size. Whenever you Google a question, you're probably going to wind up being taken to a site called Stack Overflow, which is the site where most of the programmers ask and answer questions. Well, that's kind of lame, but I guess it'll work. Let's give it a shot. This will probably be the last thing we do. Say I want a list of numbers that is 1,000 long. Here's what that site is telling me I can do. I want it to be all filled with zeros, but I want 1,000 of them. And then let's print out the nums to make sure that that worked. And it worked, I think. That's pretty cool. I will remember that. Do you have to remember it? No, but I'll probably use it more and more because don't necessarily make this change. But up here, when I did this business, I could have just done this. Tally is equal to, and I want every element to be a 0, but I want there to be 13 of them. Isn't that nice? I should do that. Maybe I'm going to delete that line. Yeah. Cool. All right. Forgive me for being overly thrilled by that. Okay. So I think I'll just comment this, why I did this. Create an array of 1,000 elements. The same syntax would work if you wanted something else other than numbers. Like if you wanted strings. If you really like the word, like Donald, we want to make Donald happy, so we're going to repeat his name 1,000 times. So here we go. Donald, end quote, end brace, times 1,000. And now when I print out, why did I call that nums? Anyways, print out nums again, it's going to print out Donald 1,000 times. Hey, neat. All right. So that's a good point to stop. We'll make the Dropbox for it. Do we have any homework queued up with the idea of lists? Homework. Create an array called heroes. Put the names of 10 characters. Books, comics, movies, TV shows, or just names you make up. You know, your family, they could be heroes. Print them out with a for loop. Like for I in range, and then print them out with a for each loop. Remember, the word each is just for our convenience. For element in L, meaning our list, which you're probably going to call heroes. All right, so that's our homework. It's all based on what we've done here, right? So it ought to be pretty fast. All right, Dropbox time.